In this video, we discuss the effect of a common ion on the solubility of a sparingly soluble salt. Alright, so let's think about a problem with silver chromate, which is this salt. Silver chromate dissociates into silver and chromate ions. So the first thing that we can do is try to see what would be the solubility of the salt just by itself, knowing that the solubility product of this salt is equal to 9.0, 10 to the minus 12. Okay, so this is your typical problem in solubilities in which you simply have to map the concentration of the ions that you get in solution through the solubility product into the solubility of your sparingly soluble salt. Okay, so for every mole of silver chromate that dissociates, notice that you get 2 moles of silver ions and 1 mole of chromate. Of course, because the solubility product is the product of those two things, okay, multiplied by the powers of the stoichiometric coefficients, then you end up here with an algebraic expression that depends on the solubility. Notice that the concentration of silver ions will be twice the solubility, and then the concentration of chromate ions is the solubility. Right. So from here you can come up with with the value of the solubility of silver chromate of 1.3 10 to the minus 4 molar. Right. So again, this is your typical solubility product. But now we're going to change this a little bit by trying to dissolve the silver chromate into a solution that is not only water, but it already contains some silver ions. So for example, suppose that we have silver nitrate present, okay, which we can write up here, silver nitrate, which fully dissociates, that is a strong electrolyte, fully dissociates into silver ions and nitrate. Okay. And the concentration of that silver nitrate that we put in the solution is 0.1 molar. Okay. So the question is as follows. Now you try to dissociate or solubilize that silver chromate, but the initial concentration of silver ions is actually not 0, it's 0.1 molar, which is coming from that silver nitrate. In the initial concentration of chromate will be 0. Okay? And now the salt is trying to solubilize in this environment, because the way to solve this problem is through an ice diagram. The idea here is that these are going to be your initial concentrations of the ions, but then there's going to be a change caused by the dissolution of that silver chromate, and that change is going to be plus 2x, where x is the solubility of the salt, and then x plus x by chromate. So at equilibrium, what you will get is that your total concentrations will be 0.100 molar plus 2x, and then x. Alright, so then you can come back to the solubility product here, and then change these concentrations from what you had before to those at equilibrium once you have those 0.1 molar silver ions in solution. Okay, so notice that your equation now is going to be 0.100 plus 2x squared multiplied by x. Okay, so that will be the equation that you need to solve. Right, a question here is whether you can invoke any approximation that is going to make the algebra a little easier. And the answer is yes. Notice that the solubility product is a very small number, 10 to the minus 12. What that means is that the solubility is likely going to be a very small number as well. Okay, what that means is that you can go to this parenthesis, and then what will happen is that this 0.100 will be much larger than the 2x, which is twice the solubility. Under that approximation, then this equation is much simpler to solve. You simply have that, and then the solubility that you get out of that will be 9.0, 10 to the minus 10 molar. Okay, clearly the approximation works well, because notice that this number, 9, 10 to the minus 10, is much more than the 0.1 number that you have neglected it against. Okay? Alright, so something that is important here is that the solubility changes from when you have the salt trying to dissolve in pure water to the salt dissolving in a solution that already has silver ions. This makes perfect sense when you think about the Le Chatelier's principle, right? If this is an equilibrium, okay, what happens here is that, well, if you add more products and you have an equilibrium in the regular case, then the system will be displaced to the left and the solubility will decrease. In this case, we see a change in the solubility of almost 10 million as you go, or about 1 million when you go from the pure water to water that contains silver ions. Okay, so in this video we have seen how to treat the solubility of a salt when you have a common ion already present in solution.